Hello. While lists provide powerful functionality for handling arbitrary data collections, when it comes to vector or matrix operations and numeric arrays, lists are not that useful. Because in general, lists don't have to be numeric, and they don't have to have the specific numeric functionality like element-wise addition or matrix multiplication, for instance. Fortunately, there's a model Numpy that bridges the gap. It provides an additional data type, Numpy array, which is a single or multidimensional vector of numeric elements. Numpy arrays inherit most of the functionality from a generic list, but also provide a broad range of matrix and vector operations for it. So now, in order to start using Numpy, we need to first import the module, and we can introduce a short acronym NP for quick reference. Perhaps the easiest way of creating a Numpy array is by converting a list to it using NP array. It will look similar to a list, but will show up as an array. And now, all the arithmetic operations with it are by default element-wise. If we add one, we add it to all the elements. If we multiply by 2, we multiply all the elements by 2. And this way, we can get the array of squares of all the elements of the original array. We can also add arrays element-wise, provided that they have the same number of elements. Or we can subtract them, or multiply, or divide, for example, etc. Now, let me consider an example of an array of air temperature readings in Fahrenheit. If I want to make sure that all those elements are treated as floating point numbers rather than integers, I may want to specify it explicitly using dtype. Now let's convert those temperature readings from Fahrenheit to Celsius using a simple element-wise operation, just like we would do it with a single number. So subtract 32 corresponding to 0 Celsius, 32 Fahrenheit, and divide by 1.8. And this way we apply these operations to all the elements of the array, getting the array of temperatures in Celsius. Also, there's a number of built-in methods returning various properties of arrays, like mean, average temperature, or standard deviation. Now let's try to find abnormally high temperatures, say those above 80 Fahrenheit. In order to do that, let us first create an array of logical elements being true every time the temperature is higher than 80. Note that this comparison is also performed element-wise. So for every element of t, we get a logical condition applied to that and return an array of the results. So true corresponding to each outlier. If I want to know the number of those outliers, I can simply sum up the elements of this array, and trues will be treated as ones and false as zeros. So I get 2 trues, 2 outliers. If I want to know those outliers, I can index an array using this logical array of conditions. Every time the condition is true, it will return me the value of the corresponding outlier. So we have 2 outliers, 84 and 83. I can also do it in just one single line of code, but I wanted to show the process step by step first. So this is how Numpy works: creating an array, indexing it, performing element-wise operations. Later, we'll also discuss multidimensional arrays and matrix operations. Stay tuned.